Well, turned out that we have enough time to cover this. The application layer protocol. What's defined in a protocol like this? First thing, well, application layer protocols are essentially exchanging messages between the processes. So we need to define type of messages that we exchange. Now, you see earlier, I often use the web as an example. So we send web requests. As a result, the server sends back the web response. So there are two types of messages. Now, depending on how complicated your application layer protocol is, there could be more than two types of messages. And then we need to define the syntax of these messages. For example, web response might say, okay, everything is fine, 101. Okay. And sometimes it says, oh, something is wrong, 403. Yeah, some of you might have seen messages like that saying, hey, yeah, page not found, 404. Okay, so those are message syntax. So there are special things or fields in the messages that's telling the client what's going on at the server. What is the service being requested? Is it okay? Am I providing the services? And what time I'm providing the service? And when is the service last available? And when is the last time you have requested the services? So there are all sorts of things these messages might be defining and indicating the status of the exchange. All right, so oftentimes multiple fields, not just the type of message, not just the specific status of the service, but also time, operating system of the server, etc. And then, hey, I use 404 as an example. What does that mean? Yeah, in the protocol, what's also defined is that for these code words, they are often short for communication purpose. But behind each number, behind each special term, there might be quite a set of semantics. So, meaning of information in these fields. And then, last but not the least, the rules about exchanging the messages. The server process might be sending back a response after it receives a request. Okay. But some applications, such as P2P, these exchanges of messages can be a lot more complicated. So, typically in an application layer protocol, you see, we need to define how many messages and define the types. Define fields in each of these messages so that they can provide important information to the other side. And for engineers like us to understand, what is the meaning of these special code words, special keywords? And then the flow of how these messages gets exchanged. Right? Now these protocols can be categorized based on whether all these rules, definitions are provided open to the public or private, so it's more secretive. Some of these popular applications we know are open. So there's this document, RFC, Request for Comment. Each protocol has one of these RFCs. Some protocols, more complicated, will have multiple RFCs. If you look up one of these RFCs and read the content, you'll see, wow, there's a lot of details one needs to put in, a lot of effort there in order for one to implement, for example, a web browser such that it will interoperate with any web servers on the internet. So web servers can have different implementations, just like web browsers can have different implementations. We have Safaris, Chrome, Firefox, etc., etc. Each of these web browsers need to be able to work with each of the existing web servers, Apache, Nginx, etc. All right. Now, you see, web, HTTP is one such open protocols. Therefore, we see a rich variety of these processes that we could download and install. Email also, right? Email readers, nowadays there are many different forms. One can also download free email server as well as proprietary email servers. Now, the email readers and all these email servers will need to be able to interoperate. With protocols being open, we could have a variety of them working together. So what's nice about this is such that, hey, better programmers, better teams show up, they could actually improve the performances of the servers or the clients. Therefore, we get faster web services, faster email services. Now, proprietary protocol, yeah, it's all secretive. You can't find any definition of it. But sometimes hackers who are a bit bored may try to hack. I think some 10 years ago when Skype just showed up, because it was super hot, because it worked quite amazingly. People worldwide can just call each other for free. So there were some hackers trying to sort of backward engineer Skype's client, and therefore they could implement some other clients, allowing other people to call up using Skype. That was a very ambitious project. I've tried it. It kind of worked. But Skype learned about that hacked client and then quickly changed something, and that hacked version stopped working. So that's what's wrong with the secretive protocol. But that's also right about the that's also what's nice about the secretive protocols, because then it will fend away all the competitors. Okay, so until today, Skype is still Skype. There's only one Skype program that you download. But we do have other forms of competitions. Nowadays, we download Line. We could also download Google Hangout. Yeah, but your friends will have to, switch to these other platforms. Good. So that's going to be all for this week. I'm just going to stop the video right here.